Good day to each and everyone. I am Mary Claire Flores from BSN Sciences 3A. So for today's video, we will tackle about the comparison with other planetary system. Okay? Okay, so alam naman natin, di ba, yung stars like our sun, napo-form siya when dense region in a molecular cloud which is made of gas and dust feel an extra gravitational force and begin to collapse. And then this is a runaway process as the cloud collapses, the gravitational force gets stronger, concentrating material into a protostar. That will be our lesson for today. But roughly half of the time, this protostar will fragment or be gravitationally bound to other protostars, forming a binary or multiple star system. And then that stars that are gravitationally bound and orbit each other. Okay, so please observe the picture. We are using two different filters. Okay, so figure 1 shows the protoplanetary disk in the what? Orion Nebula. So the Hubble Space Telescope imaged this protoplanetary disk in the Orion Nebula. So it is a region of an active star formation. Okay, using two different filters as what I said earlier. Okay, so the disk is about 17 times the size of our solar system. Did you know that? Well, we will tackle this in this video, okay? So it is an edge of orientation to us, and the newly formed star is shining at the center. Yan, nakikita nyo, the center of the flattened dust cloud. And then the dark areas indicate absorption, not an absence of material. Okay, remember that. The dark areas na nakikita natin sa picture is nag-indicate yan sa absorption. Hindi po absence ng material. Okay? But in the left image, kanina right po yung nakikita natin, yung pong tinutukoy. Ayun, tutukoyin po natin yung left image po. Okay. And then, we see the light of the nebula and the dark cloud. On the right image, a special filter was used to block the light of the background nebula. But you can see gas above and below the disk set to glow by the light to the newborn star hidden by the disk. Okay, yan po yung discovery natin sa other planetary system. Many of the circumstellar disks we have discovered show internal structure. And then, the disks appear to be what? Donut shape with gaps close to the star. Okay? And that gaps indicates that the gas in the disk have already collapsed to form large planets. And the newly born protoplanets are too small and faint to be seen directly, but the depletion of raw materials in the gaps hints at the presence of something we call invisible, so in the inner part of the circumstellar disk. And then that is something, is most certainly one or more planets. Okay, now we have a picture naman. Okay, here in our figure 2, please observe the picture. We have A and B. Okay, this figure 2 shows the protoplanetary disk around the HL tau. Okay, or 2. And as in TAU. Okay, kanina sa figure 1, it shows the protoplanetary disk around the Orion Nebula. But ngayon po, sa figure 2, protoplanetary disk around the HL tau. Okay? Okay, this image of a protoplanetary disk around the HL tau was taken with the Atacama Large Millimeter per Sub-Millimeter Array or ALMA, which allows astronomers like us to construct radio image that rival those taken with visible light. And then yung B po, it is newly formed planets that orbit the center star, clear out dust in their paths. And then just the theoretical models predict. Okay, this computer simulation shows the empty lane and spiral density waves that result as a giant planet is forming the disk. Within the disk, okay? So this planet is not shown to scale. Okay, remember that. Take note. Okay, yung figure 2 po natin, it shows HL Tau, which is a 1 million year old. Alam niyo ba yan? 1 million year old newborn star in the Taurus star forming region. Okay, but remember, Remember this. As the mass of the protoplanets increases, they travel in their orbits at speed that are faster than the dust and gas in the circumstellar disk. Okay, remember that. As the protoplanets flow through the disk, their gravitational reach begins to exceed their cross-sectional area and they become very efficient at sweeping material and growing until they clear a gap in the disk. Okay, yung image 2 po, yung figure 2 po shows us that the number of protoplanets are forming in the disk and that they were able to form than our earlier ideas had suggested, all in the first million years of the star formation. Okay, ngayon, naintindihan po ba natin yon? Okay, ngayon, dito po tayo sa discovering exoplanets. Paano ba yan na-discover, ma'am? Okay, di ba? We think, di ba, talagang iisipin natin na dahil sa advanced telescopes na yan and detectors that meron sa ating mga astronomers ngayon, they could directly image planets around nearby stars, which we called exoplanets. Yan po yung tawag niyan, okay? Okay, may technique po tayo dito. First technique po natin that yielded many planet directions is very high resolution stellar, what we called a spectroscopy. Okay, remember that. And the Doppler effect lets astronomers measure the star's radial velocity. That is the speed of the star towards us or away from us relative to the observer. Depende po yan sa observer. So, if there is a massive planet in the orbit around the sun, or kapag may massive planet po na nag-orbit around the star, the gravity of the planet causes the stars to wobble or nagbabago po yung radial velocity niya by a small but detectable amount. And the distance of the star does not matter. Remember that, The distance of the star does not matter as long as it is bright enough for us to take very high quality spectra. Okay? So now we have our second indirect technique. Meron kanina po natin is direct technique. Pero ngayon po, second indirect technique. Ito po ay based on the slight dimming of a star when one of its planet transits or crosses over the face of the star as seen from Earth. Okay. Pero yung mga astronomers po natin, hindi po nila nakikita ang planet directly but only detect its presence from careful measurements of a change in the brightness of the stars over a long period of time. Remember that. So, if the slight dips in brightness repeat at regular intervals, ma-determine po natin yung orbital period of the planet. From the amount of starlight obscured, we can measure the planet size. Okay? Posible pala. Okay, now, we need to analyze the data. Meron po tayong data dito. We need to analyze the data to correct for such biases or selection, indicate that yung small planets like yung mga terrestrial planets in our system or our solar systems are actually much more common than giant planets. Also, relatively common are super Earths. These are planets with 2 to 10 times the mass of our planet. Okay, here in our figure 3, we have transiting planets by size. So this bar graph shows that the planet found so far using this method, or the vast majority found by Kepler mission, that the orange part of each bar indicate that the planets announced by Kepler or Kepler theme in May 2016. Note that the largest amount of planets found so far in two categories that we don't have in our own solar system. Planets whose are size is between Earth's and Neptune's. Okay? Okay, lastly, we have comparison between theory and data. Okay? Many of the planet system discovered so far do not resemble our own solar system. But consequently, we have to reassess some aspects of the standard models for the formation of planetary system. Okay? Science sometimes works in this way, with new data contradicting our expectations. Diba? Na-experience natin yan. Okay? We need to press often talks about scientists making experiments to confirm a theory. Indeed, comforting when new data support a hypothesis or theory, so increase po yung confidence natin sa ating result. But now, okay, so now, it is it is still unclear how the spiraling planet stops before it plunges into the stars. So our best guess is that it plunged into the stars is the fate for many protoplanets. However, clearly, some migrating planets can stop their inward motions and escape their destructions, since we find that hot Jupiters in many major planetary systems. Okay? Okay, so to summarize all I have discussed earlier, the first planet circling a distant solar type was announced in 1995, and 20 years later, thousands of exoplanets have been identified, including nandito yung planets with sizes and masses between Earth and Neptune, which we don't have in our own solar system. So a few percent of exoplanet system have hot Jupiters, which is massive planets that orbit close to their stars, and many of the exoplanets are also in eccentric orbits. And these two characteristics are fundamentally different from the attributes of gas giant planets in our own solar, and suggest that giant planets can migrate inward from their place of formation where it is cold enough for ice to form. Current data po natin indicate that small, which is yung terrestrial type of solar system, rocky planets are common in our galaxy. Indeed, there must be tens of billions of such Earth-like planets. Thank you for watching. That's all po. Thank you for watching.